Alrighty, so today we're going to be looking at angles of elevation and depression, which is a really common use, especially before we had the ability to use things like GPS, of measuring things how far away they are and measuring how tall things are. So bunches of uses of it. Now, I guess the main idea of what an angle of elevation or depression is it's about humans. So if you're standing and you're looking at something far away, let's say, I don't know, some kind of tower. Yeah. When you look to the top of that tower, it makes an angle. And it also forms a right angle triangle based on some information. So what can we do? Well, we call this the angle of elevation because we are looking up. Instead, however, if we were standing at the top of something very tall, well, our eye line goes straight out, but we could look down at something below us. And we could, once again, form a right angle triangle. And if we could measure that angle, that would be an angle of depression. Now, in the olden days, in order to work any far distances out, it was much easier to use trigonometry to do it rather than trying to measure things by hand. In fact, you can measure anything from how tall a tree is or how tall a building is by just being able to measure the angle of elevation and how far away you are. And it turns out that measuring distances on the ground is a lot easier than it can be for other things. Or for example, if you're at the top of a cliff and you want to know how far away a boat is, well, as long as you know how tall the cliff is, you can work out how far away the boat is from you using just the angle of depression. So it's a really powerful trick. It's often used in tan because we're usually dealing with the lengths and the heights. So that's the line on the ground and then the height. And so we're usually going to be dealing not with the hypotenuse at all. So let's have a look at an example. And with any worded question, drawing a picture really helps. So if a surveyor stands 50 meters from the foot of a skyscraper, using a clinometer, she measures the angle of elevation. Now, angle of elevation means that she's looking straight and she's measuring this angle as 47 degrees. And she's standing 50 meters from the foot of the skyscraper. Alrighty. Right, so she's standing 50 meters away from the skyscraper and she measures the angle of elevation as 47 degrees. Alrighty. Now, interesting part about this is that we're kind of making a bit of an approximation because we actually need to know how tall she is, right? Because we're going to be able to find this distance here, but we won't be able to work out this distance here. So we're just going to assume that we're getting a pretty good approximation for the height of the building. But as you can see, you do sometimes need to be aware of, not necessarily getting the whole thing. And I'm guessing that this building is quite tall. And since it's quite tall, a person's about 1.5 meters tall, so you can imagine this answer is pretty correct, but maybe plus one, maybe 1.7 meters or 1.6 meters, depending on what we want to use as an approximation for an average female height. Alrighty, so we've got a right angle here, 47 degrees here. This side down here is the adjacent, and this side over here is the opposite. Like I said, we do a lot of tan because that is TOA, so tan theta equals opposite over adjacent. Tan of 47 degrees equals the opposite h, what we're looking for, over a 50. This is a number on the bottom, so we're going to times both sides by 50 to get h by itself, and we get 50 times tan 47 equals h. So h is going to be equal to 53.62 meters. Now it says to the nearest tenth of a meter, so it means we're going to actually round it to just 62 meters. Now, Again, this is an approximation. In reality, it's actually a little bit taller because presumably the surveyor does have some height as well. So we're just missing however tall she is. And that's what we'd add to our answer. But in this case, we're not worrying about it. The next question is interesting. Determine the angle of depression from the top of the building to the surveyor's position. So from the top of the building to the surveyor's position. Well, this is a parallel line to the ground. This is a parallel line to the ground, and this is the ground, so it's parallel to itself. Well, if you have a look, we've actually got a Z rule happening here. We've got two parallel lines with a line in between. So we don't actually need to do any calculations. Why? Because when you've got an angle of depression, well, the opposite angle of elevation is actually identical. So therefore, this angle here, this was for part A, for part B, angle of depression is always the same as the angle of elevation because of the Z rule. So angle of depression, no calculations needed, is 47 degrees because those angles are exactly the same. Alrighty. See you in the next one. Goodbye.